In this video, we will see about the Smith chart. So Smith chart having a lot of advantages. In the antenna point of view also, for the impedance matching purpose, we can able to use this particular Smith chart. Actually, it is a combination of the complex gamma plane and complex impedance plane. So impedances we have to represent in the complex gamma plane. Okay. Impedances are to be represented in complex gamma plane. So first of all, gamma L, if you take, it is the load reflection coefficient, ZL minus Z0 by ZL plus Z0. In general, Z0 is real, but ZL can be complex. So totally, gamma L can be complex. So it can be represented as gamma L can be U plus JV. Real part is U, imaginary part is V. Or we can represent in the polar form also, like magnitude of gamma L with certain phase phi L. Magnitude of gamma L e power j phi L. Like this we can represent the entire ZL value. So in this Smith chart we have to represent the normalized impedance, not the impedance. So if you have load impedance and characteristic impedance, you have to calculate the normalized load impedance ZL bar. That is given by ZL by Z0. As I said, ZL can be complex. It can be written as resistance part plus J into reactance. Like this we have written. Okay. Now our job is to represent this normalized load impedance onto the complex gamma plane. So we have here two planes. Okay. You can take this is complex Z plane and this is complex gamma plane. And we know that gamma is in between -1 to +1. As it is gamma plane, it is the real part of the gamma we have represented with U. It is imaginary part of the gamma we have represented with V. In case of normalized load impedance, the real part is resistance and imaginary part is reactance. So above the x-axis, we have reactance is positive, that means it is inductive in nature. Below the real axis, the reactance is negative, that means it is capacitive in nature. So on the real axis, we have resistive nature. Because on the real axis, there is no reactance. So resistance nature will be there on the x-axis only. So generally, if this is the point, then we can represent the circle with this particular radius. So that is nothing but magnitude of gamma L. And this is making certain angle phi L with the real axis. So this point will be magnitude of gamma L at an angle of phi L. This is a way of representing the point in the complex gamma plane. So in polar representation, mod gamma L as the radius of the circle and phi L is the angle made by the line with the positive x-axis or the real axis of the gamma R. That is what we can able to do. But in case of the impedance ZL bar, we have taken like some resistance part and reactance part. So if this is the point, you can represent here, this is R and this is Jx. Okay. So like this we can able to represent. Now we know that ZL is equal to Z0 into 1 plus gamma L by 1 minus gamma L. Already we know about this. So what I am doing is now I am performing the normalization of the ZL by dividing with Z0. So this is equal to 1 plus gamma L by 1 minus gamma L. But I have considered gamma L as U plus JV, and in the denominator also I am writing that one U minus JV, minus U minus JV. So here real part is 1 plus U, here real part is 1 minus U. We can perform here rationalization so that 1 minus U is multiplied with JV by 1 minus U plus JV. So this ZL by Z0 itself is ZL bar. That is what we can write. So next, this ZL bar is actually R plus JX, that is equal to, now we have to multiply these two. So 1 plus U, 1 minus U is 1 minus U square, and 1 into JV is JV, and JV into U, that means JUV. Next 1 into JV is JV, next minus JUV, next minus V square. This is what we have written. Okay. By the denominator is looking like A minus B into A plus B, that means A square minus B square. So A square is 1 minus U square minus B square, that means J square V square. So J square is again minus, so like this we can write. So finally JUV minus JUV will be cancelled. Okay, so what we can write now? R plus JX, and we can compare the real part and imaginary part also. So directly I'm writing. So in the next step, I will take, by equating the real parts, R is equal to 1 minus U square minus V square by 1 minus U whole square plus V square. Then by equating the imaginary parts, what you will get? X is equal to, imaginary part is 2JV. That means 2V by 1 minus U V square plus V square. Now we are going to rearrange these two equations. Just cross multiply. R into 1 is R into U square is RU square, R into minus 2U R plus R into V square is equal to 1 minus U square minus V square. So send all the terms to the left side. So U square means we'll get R plus 1 into U square, then R plus 1 into V square minus 2R into U. Then what are the remaining terms? We have R minus 1 is equal to 0. Later, divide this entire equation with R plus 1, so that U square plus V square minus 2R by R plus 1 into U plus R minus 1 by R plus 1. It is looking like a circle equation. Circle equation, x square plus y square plus 2ax plus 2by plus c is equal to 0, with the center will be minus a comma minus b, and radius will be square root of a square plus b square minus c. This is what we can write. So now the variables are u and v, and a is here, otherwise I am writing directly center. Center will be r by r plus 1 comma 0 and radius will be square root of r square by r plus 1 whole square plus 0 square minus r minus 1 by r plus 1. Okay, then this r is equal to what we can write here? We can take LCM is r plus 1 square. So here r square and it is r plus 1 means minus r plus 1 into r minus 1 is r square minus 1. That means r square plus 1 we get. So it is equal to 1 by r plus 1. So finally, this equation is representing the circle equation. If you fix r value, then that is representing one circle. If you change the r value, then you will get another circle equation. That means based on the r value, so here I will write center and radius at one place. Center is r by r plus 1 comma 0 and radius is 1 by r plus 1. You see, if you fix r value is equal to 0, you will get 0 comma 0 is the center and 1 is the radius. And if you take r is equal to 1, 1 by 2 comma 0 is the center and 1 by 2 is the radius. That means if you fix the r value at different values, you will get a different circles with different centers and radii. Okay, so that is why this equation is said to be family of constant r circles. If r is constant, it is giving one circle equation. If you fix another constant value for the r, you will get another circle equation. So this entire equation is representing the family of constant resistance circles. Okay, now we'll see how these circles are available. Okay, so now I'm taking r is equal to 0. So center will be 0 comma 0 and the radius is 1. If I take r is equal to 1, center will be 1 by 2 comma 0 and the radius is 1 by 1 plus 1 means 1 by 2. And r is equal to 2 if you take, then 2 by 3 comma 0 is the center and 1 by 3 is the radius. R is equal to infinity if you take, what will you get? R by r into 1 plus r comma 0 is the center. So these two will be cancelled. So it is 1 comma 0 is the center with the radius is equal to 0. Whenever radius is equal to 0, this is representing the point circle otherwise. Okay, now we have to draw all the circles. So few values of resistances I have taken, those are leading to different circles. Now we'll get some idea. But these circles are to be drawn on the complex gamma plane. So see carefully. As we know, here real part of the gamma u is available and imaginary part of the gamma here v is available. There is j. So the maximum value of the gamma is from -1 to +1 only. So this is 1, this is 0, this is -1, this is 1, this is -1. Like this I have to. These are the values of gammas. Okay, don't forget that one. Now if you take r is equal to 0, with center 0, 0, with radius 1, you have to draw the circle. Okay, so this is representing as r is equal to 0 circle. Okay, next if you take r is equal to 1, okay, I'm talking about this one, we'll get another circle equation with center 1 by 2 comma 0 and 1 by 2 is the radius. So see carefully, here 0 is there, here 1 is there. So 1 by 2 will be at the center. So here 1 by 2, this is 1 by 3, this is can be 2 by 3. Like this we can write. Okay. So now when you take r is equal to 1, 1 by 2 comma 0 is the center and 1 by 2 is the radius. That means this is the center with radius is 1 by 2. That means you are going to get the circle is like this. So this is r is equal to 1 circle. Okay. Then now if you take r is equal to 2, 2 by 3 comma 0 is the center. So this is the center with radius is 1 by 3 only. So this is the circle we got. Okay. So that is nothing but r is equal to 2 circle. Now if you take r is equal to infinity, at 1 comma 0, you will be having the radius is 0. That means this point itself is r is equal to infinity. Okay. So like this we have taken. Now if you take r is equal to 0.5, you may get like this. Okay, you may get like this. So in this way, you will get the family of constant r circles. Okay, so for different values of r, different circles you will get. And the maximum circle is r is equal to 0 and minimum one is r is equal to infinity. That is representing the point. And like this, you will be having the constant r circles. Now we will see about constant x circles. Already we have got the expression like this. Okay, now I am taking this expression. Okay, then just cross multiply this one. X into 1 is x plus x into u square minus 2u into x plus x into v square is equal to 2v. Then I am rewriting this one like x into u square plus x into v square minus 2x into u, then minus 2v plus x is equal to 0. Divide this entire equation with x. So u square plus v square minus 2u minus 2v by x plus 1 is equal to 0. Now compare this one with the circle equation like x square plus y square plus 2ax plus 2by plus c is equal to 0 with the center minus a comma minus b and radius is equal to square root of a square plus b square minus c. By comparing these two, you can understand that center is 1 comma 1 by x and radius is square root of 1 plus 1 by x square minus 1. That means 1 by x. So radius is 1 by x, the center is 1 comma 1 by x. Like this we have. Now again we have to draw these constant x circles. Now if we fix the x value, but x can be negative also, that is leading to capacitance. And x can be positive, that is leading to inductance. So now if you take x is equal to 0, center is 1 comma infinity and 1 by 0 is radius is infinity. Whenever radius is infinity, it is actually straight line. Okay, that is actually real axis. And if you take x is equal to 1, what will you get? Center is 1 comma 1 and radius is 1. X is equal to minus 1 if you take, center is 1 comma minus 1 and radius is, you can take here root of 1 by x square is 1 by magnitude of x. because radius cannot be negative. You can take here 1 out. Then if you take x is equal to 2, it is 1 comma 1 by 2 and it is 1 by 2. X is equal to minus 2, 1 comma minus 1 by 2 is the center, but radius is 1 by 2 only. X is equal to infinity, 1 comma 0, the radius is 0. So again it is representing the point, same point what we have seen when r is equal to infinity. So now all these circles we have to draw. So on the complex gamma plane we have to draw. So it is a real part of the gamma. It is imaginary part of gamma, that is JV. Okay, we know it is 1. It is 1, 0, minus 1, minus 1. Okay, so the context will change. Now, when you take x is equal to 0, 1 comma infinity is the center and infinity is the radius. Center itself you cannot able to catch, but center will be on this particular line at infinity distance. And with infinity radius you need to draw means you will get the bigger circle like this. This curved nature you cannot able to observe. So that is nothing but this real axis only. So just I'm erasing this one. Okay. Already I have given the point here regarding x is equal to 0. Now if you take x is equal to 1. If you take x is equal to 1, 1 comma 1 is the center. So if this is 1, this is also 1. 1 comma 1 is the center and the radius is 1. So what will you take here? Just I will take this particular diagram is just like this. Now at x is equal to 1, 1 comma 1 is the center. That means this is the center. And radius is 1 only. So we get the circle is like this. It is touching the like this touching the real and imaginary axis like this. Okay. Now if you take x is equal to minus 1, center will be at 1 comma minus 1 and radius is 1. That means like this you can take. The both circles should be symmetric. I may not draw properly. You will get like this. Okay. Then if you are keep on increasing the x value, radius is 1 comma 1 by 2 and so radius is 1 by 2, center is 1 comma 1 by 2. 1 comma 1 by 2 means here we will get and this is the circle you are getting and this is the circle you are getting. Now if we keep on changing the x values, you will get circles like this, bigger circle like this, another circle like this. Like this you will get the circles. Okay, but these are constant x circles. If you take constant r circles and constant x circles combined, that itself is a Smith chart. So how you look at it? So gamma r, gamma I, that means JV is equal to U. So first constant r circles I am drawing. R is equal to 0 circle. R is equal to 1 circle. Okay, then some more R circles I am taking. Like this we have. Then now I will take this constant x circles. So like this, the circles will be continuous. Okay, but we have to consider the constant x circles, the portion of the constant x circles which are available within the r is equal to 0 circle only. Okay, so if you take beyond that one, r can be negative or gamma is greater than 1. Those two things are not possible. So that we have to take the Smith chart will be like this. Within the r is equal to 0 circle only we have to work. This is r is equal to 0 and some constant r circles I am taking. Okay, then like this we are taking. Complete circle of the reactance we are not taking. Like this. This is what you have to understand. Okay. Then this real axis is x is equal to 0 we got. And this is nothing but r is equal to 0. And this point is 1 comma 0 actually. And this point is indicating r is equal to 0 and x is equal to 0. But at this point, if you see, this is a coordinate we got due to r is equal to 0 and x is 0. Here, this is r is infinity and x is infinity, not 0, 0. Leftmost is r is 0, x is 0. Rightmost is r 0 and x is 0. Okay. Then this is the Smith chart we are considering. So this is a complete Smith chart. Okay. Further, we can able to use this Smith chart for calculation of the reflection coefficient and input impedance or the impedance at some location on the transmission line. Okay, Vmax, V minimum, VHWR. So all these things we can able to calculate and stub matching, everything we can able to use in the Smith chart. Okay, thank you.